We've talked about the type of molecules that are able to cross the membrane without any help. So if we have small hydrophobic or nonpolar molecules, they're going to be able to pass through that phospholipid bilayer just fine on their own. But then if we have molecules that happen to have a charge to them, or if they happen to be polar, then they're not going to be able to cross. And we can use channel proteins and carrier proteins to actually get them across. Now, all molecules really would like to move down their concentration gradient, and we refer to that as passive transport. But sometimes we have a need for what we'll call active transport. And active transport is really very much the opposite of passive transport, because when we're talking about active transport, this is going to be moving molecules from a low concentration to a high concentration. So another way to describe this would be to say that we're moving them against or up their concentration gradient. And this would be similar to taking a ball and trying to roll a ball up a hill. So if we're moving a ball up a hill, then that's going to require some effort or some energy on our part to actually get that ball up the hill. So just like that, when we're talking about active transport, it is all the time going to require an input of energy. And that input of energy is going to typically be in the form of ATP. So we will see ATP hydrolysis right there next to any active transport that's taking place inside the cell. So if we take a look at this picture here, and we look at the red molecules, on the top I have a low concentration of them, and then on the bottom I have a high concentration of them. And suppose that this was something that the cell really needed. So it was something beneficial and we wanted to bring more of it into the cell. So by saying that, I'm assuming that the bottom here is really my cytoplasm. So if we had a need to actually move more of these red molecules down in this image, then that's going to be active transport. We're going to need help to do that. So when we have active transport, this is all the time going to require a carrier protein. We're not going to be able to use the channel proteins in this case, and I'll explain that in just a moment. But with the carrier proteins, so this is my carrier protein here, we're going to have one of these molecules actually enter and bind in their active site. And so if we show that here, this red molecule is going to bind, and then we're going to also be using ATP. And so when the ATP is used, we're going to see ATP hydrolysis, which means the ATP is going to be broken into ADP and inorganic phosphate. So we'll see that right next to all of this. And again, whenever we see something like that, we want to think of this, and I'm just drawing it like this, we want to think of this as a use of energy or an input of energy that's taking place. And so when that happens, the carrier protein is going to be able to change shape. And when it does that, that change in shape is going to take that molecule and it's going to be able to transport it from the low concentration to the high concentration. So that's what we see just happened here. We used some energy, we used a carrier protein, and we moved this red molecule from the low concentration to the high concentration. And ultimately what we're doing is we're building up an even bigger difference in the concentrations that we have on the two sides of the membrane. Now, if we think about the carrier protein versus the channel protein just provides a passageway. So if we just look at this one here, recall that the channel proteins have gates on them a lot of times. And these gates are really useful because these gates will allow us to control whether or not something is flowing through that channel or through that tunnel. Now, if this tunnel was open, then just the opening of it is going to cause these molecules to want to go back this way, because everything wants to go from a high concentration to a low concentration, or in other words, the ball wants to roll down the hill. So that's something that's going to happen anytime we open the channel proteins. So what that means is that we cannot use channels for active transport. Because if we open them up, then the molecules move the direction that we do not want them to go. So this is why we mentioned over here that always when we're talking about active transport, we're going to be using the carrier proteins. So just one last time to highlight the things that we're talking about with active transport. Active transport is always going to be movement from a low concentration to a high concentration. We call this against the concentration gradient, or sometimes we'll call it up the concentration gradient, because this is against the natural tendency of the molecules. In other words, they don't want to move this direction. It is going to require energy, and that energy is going to be input in the form of ATP. And then lastly, we'll always have a transport protein involved, and that transport protein is specifically going to be a carrier protein.